Okay, just to clarify a couple of things that I find students often confuse is the difference between solving an equation or maybe even finding zeros of a function versus finding a vertex. They're two very different things. First of all, you solve an equation. It's really the only thing you do to equations is you solve them for x. Now, there are a number of ways we can solve this one. This one here, I can see easily factors. So I'm going to do that. Right? This is easy because it's just x squared. The only option we have is x times x. There's a -4, which tells me the signs are different. And as far as the factors of 4 here, the only pair that adds to 3 is the 1 and the 4. Since it adds to +3, the positive is the 4 and the negative is the 1. And then you use the zero product rule to set each of these factors equal to 0, and you solve. Ooh. I don't know why I put 0 in there. Ooh. Try that again. Or x equals 1. So that's what a solution looks like. You're giving x values that makes the equation true. And you could test both of those and plug them in to see if that actually works. Now, see, so that's an equation. That's the only thing you do to equations. Okay, now, there are functions, and you can do lots of things to functions. Okay, you can find a function's domain. You can find a function's range. You can determine where a function is increasing and decreasing. A number of things. You can add functions together, multiply functions. You can find, say, what's called critical points of a function. For example, on a parabola, a critical point could be the vertex, a max or min. There's many, many things that you can do to functions. An equation, the only thing that you ever do to an equation is solve for x. That's it. There's our answer. That's it. There's nothing else you can do to it. So notice I now have two functions here, right? Notice I have one here and I already have one written over here. So there's two different functions. Now, as far as the function goes, you might be asked any number of those items to solve for. Okay? If you're asked to find zeros or vertex, there's two completely different things going on there, and you have to do two completely different things to get the answer as soon as you see a function. And also with an equation, there's multiple ways that you can solve an equation. We have factoring, we have completing the square, we have quadratic formula, we have graphing calculator, and you're going to get the same answer every time. But for a function, you can be asked numerous things, and you have to determine maybe, one, the best way to do that, and two, make sure you're actually answering the question. All right, so here, let's just say it says find the zeros. So if the question said find the zeros, this would be very similar to what we just did. To find the zeros, zeros are where the function is equal to 0. So if you have a function, this function, equal to 0, this means that this function, x squared plus 3x minus 4, is then equal to 0. That's what we're asking. If you try to find the zeros, you're saying, okay, I want to know the x values that make this function equal to 0. Well, look what I just wrote. I wrote the function is equal to 0, and it looks just like the problem up here. Okay, so we just need to solve for that. Well, you can do whatever you want to solve that. Okay, you can factor what we just did. You can use the quadratic formula. So to be able to do this, you can factor, and we already did that. All right, you can factor, you can quadratic formula. You could even complete the square. What else do we have? Graphing calculator. Okay, so there's numerous ways to do that. But again, you're looking for the zeros. So if you're factoring quadratic formula to complete the square, you're going to get the same answer. With graphing calculator, you're looking for zeros, right? If you use graphing calculator, you're looking for zeros which are on the x-axis. You are not looking for the vertex. You're looking on a graph for where it crosses the x-axis, and it will tell you the zeros of the function. Okay, and also we are looking for two answers. Now, we'll come back to a different problem like this, and I'll show you how to complete the square to do this. But let's first find the vertex of this function. Okay, so just find the vertex. Well, there's two ways to do that, and we might as well. Okay, two ways. So method number one is complete the square. And there's actually a couple ways to do it. You can use a graphing calculator too, and other ways, but I'll just show you these two ways. So one is complete the square. So that means, now this is not an equation to solve. We're not solving this. We're not setting it equal to 0, because that means you're solving an equation or you're finding the zeros of a function. We're not setting this equal to 0. That does not give you a way to find a vertex at all. All right, so to complete the square on this one, to actually find a vertex, okay, this is where you take the -2 and you move it over a little bit. Okay, and then you can change colors here. Oops, I don't want to do that. Let's go. Okay, so then you write down what b is. B is 8. B over 2 is 4, and then b over 2 quantity squared is 16. So the 16 is what we're adding right here. Now, if this were an equation, you would write plus 16 on one side, you'd write plus 16 on the other side. This is not an equation. This is a function. So whatever you do to this side of the function, you have to do the opposite to counterbalance what you just did. So see, if I were to simplify this entire side, the 16 minus 16 would cancel, and you'd only be left with what's in the blue is what's right here. Okay, then you're going to rewrite this right here as x plus 4 quantity squared, and then you just simplify this right here, which is -18. And then I'm going to come back and write f of x here. So this is not the answer. This is just rewriting the function, or this quadratic function, in vertex form. So then we can easily find the vertex from this. We can easily find the vertex because, like, obviously this is called vertex form. So there's a reason for that. And the reason is the vertex is then going to be -4, -18. Okay, and we've graphed these. We should know that the plus 4 moves left 4, the -18 moves down 18, and there's a vertex. Okay, method number 2 would be the, say, x equals -b over 2a method, or just the algebraic way. Well, this is algebra, but a direct way to find the x value of the vertex. So we're going to do the same thing to the same exact function. Okay, but I'm going to use x equals -b over 2a method. Okay, so x equals, and that's important to write down. A lot of you ignore writing that down. I don't know why. It's part of the formula. So negative of b. So negative of b is 8. So I write that down. Over 2 times a. Now in this case, a is 1. So just a 1 right there. And that gives us that the x value of the vertex is -4. That is no surprise because we got a -4 right up there. Now, to find now that gives us the x value of the vertex. And then to get the y value, you just find f of -4. You just plug that in. It'll tell you right on the graph where that crosses. So, no good software updates. Perfect. Okay, so f of -4. So I'm plugging into the function. Okay, and let's see here. We get a 16. We get -32. And then we get a, oh, this is a -2. Let's erase that. Yeah, this is a minus right here. Okay, -32 minus 2. I knew something was wrong because I just did that in my head and I was getting the wrong answer. Okay, so 16 minus 32 is -16. -16 minus 2 is -18. And again, we have the vertex now, which comes from the -4, which is right there, and the -18, which is right there. All right. Let's solve this. We're going to solve it 3 different ways. First way, let's do it by factoring. All right, so let's write this down. All right, if I'm going to factor, first thing I'm going to do is see if there's any GCF. So I see a 2 goes into 2, 12, and 6. So I'm going to GCF that. Let's see. Yeah, -3 is equal to 0. And then I'm going to divide both sides by 2, or you could just kind of ignore that because there's no x. And then what you get is x squared minus 6x minus 3 is equal to 0. Okay, so I GCF'd it. Okay, so even though I said I wanted to solve this by factoring, this doesn't factor anymore. There's no factors of 3 that adds to a -6. So I have to stop my factoring and I have to do something else. Okay, you can't just stop and say no solution. So right here, we have a couple of choices. You can complete the square. You can quadratic formula. Okay, now I was going to solve this several different ways, but just seeing this right away, it looks like since at this point we can't factor anymore, that at this point I am now going to show you either the quadratic formula or the completing the square. All right, so let's get rid of this one factor. So I'm always going to attempt to factor. Now let's say, okay, I can't pick, okay. 1 from here, I now have to take this x squared minus 6x minus 3, and I'm still working with this now. Okay, so let's do quadratic formula on this. All right, so to help us, I'm going to identify a, b, and c. A is 1, b is -6, c is -3. Okay, so x equals, again, very important, x equals -b. So b is -6, so -b is 6. Plus or minus square root of b squared. I'm going to put that -6 in parentheses. Minus 4 times a times c. All over 2 times a, which is just 2 times 1, which is 2. All right, we now need to see what's going on inside the parentheses. So you can put that in your calculator without the square root. All right, so let's just do this. See if I can do this by hand here. So -6 squared is 36. -4 times -3 is 12. So it looks like we get a 36 and a 12, which should give us a 48 underneath the parentheses. Okay, we now need to simplify square root of 48. I'm going to take the square root of 48. And by now, we should know that we're going to split that up using perfect squares. Remembering the perfect squares, the largest perfect square that goes into 48 is a 16. You should have those memorized. I'm not going to write them down because you should have those written down and or memorized somewhere. So 48 is divisible by 16, and 16 goes into 48 3 times. And then the square root of 16 is 4, and the square root of 3 does not simplify. So that's what's going to come back over here. And we have 6 plus or minus 4 root 3 all over 2. Okay, we now need to look and see if any number goes evenly into 6, 4, and 2, ignoring the root 3. And I see that a 2 goes into all those, so I'm going to divide all those by 2. So 6 divided by 2 is 3, plus or minus. 4 divided by 2 is 2, and square root of 3. And 2 divided by 2 is 1, but I'm never going to leave any fraction over 1, so we are done. And the answer is 3 plus or minus 2 root 3. Okay. Now again, at this point right here, this is what we're working with. Let me show you in red. Once you get to here, and you tried to solve this equation by factoring, I pulled the 2 out. I'm right here, and you still have a couple of methods that you can use to do this. Now, if this problem says to use algebra, the only method you can't use is graphing calculator at this point and put it in your calculator and write down the answer. Okay, yeah, if it says use algebra, you have to come up with this one, and your calculator is not going to give you that answer. All right, so now let's go and solve the same thing using completing the square. Okay, that was weird, because I picked blue, and it didn't change until after I wrote the C. Interesting. Okay, so now we're going to complete the square, solving the same thing over again. So x squared minus 6x minus 3 is equal to 0. Now, this is different than the one we did on the other page, the first screen, is that now this actually is an equation. And I'm going to take the negative 3 and take it to the other side and make it a positive 3. Okay, so this, again, is a little different here. All right, so down here somewhere, since I usually do it to the left, but I don't have enough room, I'm going to write my b is negative 6, b over 2 is negative 3, and b over 2 squared is 9. So that's the 9 that I'm going to add to both sides. I'll show you that in red. Plus 9 here, plus 9 here. Okay, then this is now a nice complete square, and you can turn it into x minus 3. Quantity squared is equal to 12. Okay, once you get this as a nice complete square, and you change it into x minus or plus or minus something squared, we need to get rid of this squared, so we need to get rid of this, and you do that by square rooting both sides. So the square root gets rid of the squared, and on the other side you have plus or minus. Don't forget the plus or minus, because look right here, it's in the quadratic formula, plus or minus square root of 12. So again, we have to evaluate that as some square root, and now we have the square root of 12, and the largest perfect square that goes into 12 is a 4. So we split that into square root of 4 times the square root of 3. The square root of 4 is 2. And the other one you keep 2 root 3. Now notice we got the same radical that's over here. And that should be no surprise because the answer is going to be exactly the same. So then we come back up here. And you substitute the 2 root 3 in for the root 12. And then we just have to get rid of the minus 3 by adding 3 to both sides. And you get 3 plus or minus 2 root 3. All right, so now this is where on a quiz you're going to have to keep this, keep all this stuff straight. And again, we're solving. So this is not, has nothing to do with the vertex. If you were to put this in a graphing calculator, these x values that we found are where it's going to cross the x-axis. Okay, it is not the vertex. You're solving an equation or finding the zeros of a function. You solve for x. Okay. If you need to find the vertex of a parabola, you use completing the square, which we did on the other page, to put it into vertex form, or you can use the negative b over 2a. If it says solve, never use the negative b over 2a formula. Again, that gives you the vertex. All right, so hopefully that clears things up. Just get all that memorized. Just to make sure that you can answer the question that is asked and that you do it in the correct way, because some techniques that we have, if you use them, you might actually be answering the wrong question. All right, if you have any questions on this video, just send me a little note, and see you guys tomorrow.